Hi there, third grade friends. It's Mrs. Hoffman again. I am so glad you are back with me today. I hope your brain is on and ready to go because today we are working with word problems. I know what you're thinking. Don't panic. We've got this. No problem. Today for our lesson, you're going to need a few things. You're going to need your student practice page. It's the one that has this little rectangle here and it says whole and part and part. You're going to need that, and you're also going to need that pencil. Remember, try to find an eraser on the end because we might make mistakes and we want to make sure that we can erase them and learn and grow. To get started today, we're going to do a quick refueling break. This is another one of my favorites. This is our lazy 8 breathing. This one you can do laying down like our little guy here, or you can sit up nice and tall with your shoulders back and down and just relax. What we're going to do today is we're going to take a big deep breath in at his head and let it out down here by his feet. And we're going to do that 4 times. All right, so when you're ready, relax. And here we go. We're going to start right here. Take a nice big deep breath in. And now let it out. Let's do it again. Here we go. And let it out. We're going to do that 2 more times. Nice big deep breath in. And let it out. Last one. Make it your best. Here we go. Great job. Now that we're relaxed and ready to go and we've got our brain settled, we're going to get started. Take a look at our goal today. Today we're going to use a bar diagram to model real-world problems. Whew, that's a lot of big words, isn't it? A real-world problem is just simply a problem that you can encounter in the real world. Most of the time, you think of them as just word problems. The other thing that we're going to look at today is a bar diagram. This is a bar diagram, and we call it that because, well, it looks a little bit like a bar. Just like our triangles from last time, do you remember this triangle? Where we had a number at the top and 2 at the bottom, and there was a plus sign and a minus sign here. So for example, we might have had a 10 and a 4 and a 6. Do you remember that from last time? A bar diagram works exactly the same way. This top part here, this 10, is going to be the same as the hole in your bar diagram. So we could replace this with the number 10. The 2 parts here, when you put them together, that represents the whole. So in this case, our 2 parts, our 4 and our 6, could go right here. So we could say 4 plus 6 equals 10. Or 6 plus 4 equals 10, just like last time. Or we can make these subtraction problems. We could say 10 minus 4 equals 6, or 10 minus 6 equals 4. So I want you to keep that visual of the triangle fact family in your head as we're working today. It's going to help you with this part and whole. Remember though, our problems are going to get big and our numbers are going to get big. And we're adding all those words in, which seems kind of scary. So we're just going to take our time and go nice and slow. But remember, part plus part equals whole. So down here, part plus part equals whole, or whole minus part equals part. So the whole, the 10, minus a part, minus 4 equals 6. Okay? Same thing, just a different visual today. Okay, so let's see if we can understand how this works. So we're going to look at our equation below and we're going to figure out which pieces go where. So think about that triangle. I'm going to draw that triangle right here. Okay, remember that the sum, or the largest number, went up here at the top. So when I look here at this number sentence, I've got 74 plus 18 equals 92. Which of those is the sum? What's the largest number? Perfect, the 92. So in our triangle, our 92 would go up there at the top. Where would our 74 and our 18 go if we were making our fact family triangle? Where would we put that? Perfect, we would put them right down here. Now remember, order doesn't matter just yet, not in this equation. Okay, so let's take what we know about that fact family triangle and let's put it here. Now remember, this top part, the number up here, is the whole. The whole is the same as the sum. So which number in our equation here is our sum? Perfect, it's 92. So I'm going to put my 92. Now that 92 represents this whole bar here. The whole thing from the beginning all the way to the end. So what are the 2 parts that make up that 92 in my equation? Exactly, 74 and 18. That's how our bar diagram is going to work. So we're going to take our sum, that's going to go on top, and our two parts, and we're going to put them on the bottom. Now this could get a little tricky later because what if one of those numbers is missing? Yikes, then we're going to have to figure out how to solve that. So remember, we have to take everything we've already learned and use that to help us solve our problems today. I think we can do it, but it's going to take a lot of brain power. So stick with me. All right, here we go. Let's take a look. Here's my equation, but what do you notice? Yeah, I have a missing part, don't I? Oh man, okay. Well, let's go back to our triangle because that's the visual that we already know. And let's take a look. We've got a whole, a part, and a part. So in here, in our equation, do we have a sum? Do we know the whole? Yeah, we do. It's that 373. So we're going to put that 373 here. Oops, those kind of got stuck together. In our bar diagram here, where are we going to put that sum? What does the sum represent? Does it represent a whole or a part? Perfect. It represents a whole. So we're going to take that 373 and we're going to put it here. Remember, that represents everything from here to here. Okay. Well, if this is the sum or the whole, what are the parts that make up that whole? What are the parts that we need to put together? Okay, that's an easy one. 127 for sure. But what goes here? What's missing? We don't know, do we? So we're going to put that question mark for that unknown number. Oh man. Well, now I know I have 127 here and I have a question mark here. Well, do you know how to solve the equation to find this question mark? Sure you do. If you know how to solve this one, then you can solve this one. So let's find really quickly what's missing. All right, well, I know that 127 plus my question mark equals 373. Okay, I know that question mark plus 127 equals 373. Does that help me? Not really. I need that 373, or that question mark, to be all the way on that right-hand side. So let's find a subtraction problem. I can do 373 minus my question mark, and I'll get 127. Does that help? Not yet, but can I do 373 minus 127 and get my question mark? Yeah, I can. Well, we're not going to take the time to solve that problem today, but that's how we would go about doing it if we got into a situation where one of our parts was missing. If our whole is missing, we just need to add the two parts to find that out. But if you have a part missing, then we've got a subtraction problem. And we're going to have to figure out how to solve that. So let's put this into a real world problem and see if we can make it work. Remember, this is tough, but if you hang with me, we'll get it. Okay, let's look. It says a pond has 357 rosy red minnows and 162 white cloud minnows. Well, how many minnows live in the pond? Okay, well, let's think about what we know. I know that part of the minnows are red rosy minnows, and I know that part of the minnows are white cloud minnows. But what I don't know is how many minnows are in the pond. I don't know how many total, right? So I don't know my whole. Let's draw another bar diagram down here. So I'm going to draw just a rectangle. I'm going to split my rectangle into two parts. I know that one part are my rosy red minnows, right? Right here are my rosy red minnows. How many rosy red minnows live in the pond? Perfect, 357. So that's one part of all the minnows that live in my pond. What's the other kind of minnow that lives in the pond? Oh yeah, white cloud minnows. How many of those are there? 162. So I know that the other part of my minnows, my minnows in the pond, is 162 white cloud minnows. Well, this is what I don't know. I don't know the whole. I don't know the sum. So what I need to do is I need to take those two parts, because remember, part plus part equals whole, and I need to add them together. So let's do that. 357 plus 162 is going to give me that unknown number. That's going to tell me how many minnows live in the pond altogether. All right, well, let's do some adding, shall we? I'm going to erase this guy down here so that I've got some space. You can just turn your paper over if you need more space. All right, so here's what I'm solving. 357 plus 162. So I'm going to use base 10 blocks to add those together. So I'm going to draw 357. 1, 2, 3, 4, 5. Oops. I guess if I'm going to draw units, I better draw single squares. 7 of them. Here we go. 1, 2, 3, 4, 5, 6, 7. Okay, there's my 357. Now I need to represent 162. All right, here's 100. And I'm going to do 6 tens. 1, 2, 3, 4, 5, 6 tens. And I'm going to do 2 ones. Okay, now all I have to do is add them together. All right, well, let's see. 7 and 2 will give me 9. Ooh, let's look at this one. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, let's put that here. And 300 plus 100 is going to give me 400. All right, well, let's add those together. Well, 400 plus 100 is 500. Plus that extra 10 is 510. Plus 9 gives me 519 minnows total. So my whole is 519 minnows. Great job, guys. See, that wasn't so terrible. Let's try another one. There are 453 students that attend Delaware Elementary School. On Monday, 37 students are absent. How many students are at Delaware Elementary School on Monday? Well, let's think about what we know. Do I know the total number of students that attend the elementary school? I do, right? I know that there are 453 students. So I know the total 453 students represents this whole group. Well, I also know that on Monday, 37 of those students are absent. So 37 represents part of my students. Well, the question is, how many students are at school if 37 are absent? So I need to know this number. So I'm going to put that question mark there to represent my unknown number. Okay, this one is tougher because I don't know both parts. What I do know is the total and one part. So let's make some fact families to help us solve this. So I'm going to start with my addition fact families. I know that if I add 37 plus my question mark, I'll get 453. So 37 plus my unknown is 453. We know that we can take those two add-ins and switch them around to make another addition sentence. So I can do question mark plus 37 equals 453. Well, that doesn't help me solve the problem because I still need to make that question mark come all the way over to the right-hand side by itself. So let's do some subtraction. To start with subtraction, we're going to start with our whole, 453. Let's take away a part. Well, let's take away 37. That will give us our unknown number. Hey, isn't that the equation we need to solve right here to figure out how many students are at school on Monday? Yeah, perfect. Okay, well, let's do base 10 blocks again. I'm going to represent that 453. Remember, it's a little different with subtraction. So let's do that. 453. So 1, 2, 3, 4, 5. There's my 50. And then 1, 2, 3. Okay, and I need to take away 37. Uh-oh. Do you see a problem? I only have 3. I can't take 7 away. Do you remember what we do in this situation? Yeah, we've got to rearrange the way we drew our base 10 blocks. So we're going to borrow one of these 10s, and we're going to redraw it over here and re-represent it a different way. So I'm going to cross out one of these 10s, and I'm going to draw that as single units right over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now can I take away 7? Sure, here we go. 1, 2, 3, 4, 5, 6, 7. Well, how many do I have left? 1, 2, 3, 4, 5, 6. I've got 6 left. I'm going to put that right down here. Okay, can I take 3 10s away from 4 10s? I sure can. Let's do it. 1, 2, 3. What does that leave me? 1 10, which we know is the same as 10. And how many hundreds? Yep, 400, because I'm not taking any away. Let's add those together. 400 plus 10 plus 6, put them all together, and our missing number here is 416. There were 416 students. That doesn't make sense. Students left at Delaware. Let's check our math on this. 453, and I'm taking away 37. Let's add. Can we add to check our math? Let's do that. If I do 416 plus 37, let's see if we get the right answer. If we get 453, then we've done our math right. So let's check that. 6 plus 7. Well, I know that 7 plus 7 is 14, so if I do 6 plus 7, I get 13. Okay. 3, 4, 5. Oh, look, our math is right, 453. That seemed kind of wrong for a minute, didn't it? Sometimes that happens in math, and we have to go back and check our answer to make sure that we're correct. You did a great job on this one. Look at all that math. That's a lot, huh? All right, let's try this one. Sarah has $630 in her wallet. Gosh, I wish I was Sarah right now. I would really like to have $630 in my wallet. She spends $274 at the mall on new clothes. Man, how much money does Sarah have left? Oh, okay. Well, let's see. I know she had some money in her wallet, so I know the total amount. How much did she have in her wallet? Yeah, she had $630 in her wallet. Gosh, I really want to be Sarah right now. She spent $274 at the mall, and my question is, how much does she have left? So what she spent at the mall and what she has left, those two parts together, they represent our 630, don't they? So what are the two parts that we know? Well, we know 274 is how much she spent. But what's the other part? How do I find that? There's no other number in my problem. Yeah, that's my question mark. That's the number I don't know. I have to solve that. It looks a little familiar. It looks a little bit like the one we did last time, right? Looks a little bit like the last problem where we had to come up with our equation to solve. Well, let's do the same thing. I know that my two parts together are going to equal my whole. So I know that 274 plus my question mark equals 630. And then I know that my question mark plus 274 equals 630. Well, that doesn't help me, does it? I guess this is a subtraction problem, huh? Because I want to know how much she has left. Okay. Well, 630 minus my question mark, my unknown, is going to give me the $274 that she spent. That's close. Okay. Well, 630 minus 274. Now my unknown is all by itself over on the right. That's perfect. This is the question that I need to solve, or the equation I need to solve to find how much money Sarah has left. Okay, let's do that. Let's use an open number line this time. Okay, open number lines, remember, are going to start with our small number, 274. And they're going to end with our large number, 630. Okay, I need to find my next friendly number, 274. Let's go to 280. If I can get to 280, then that gives me a friendly number I can count by some tens. So from 274 to 280, It's going to be a jump of 6. Now I want to go to 300 because that's a really easy, friendly number. So I'm going to go from 280 to 300. I'm going to count by tens. 280, 290, 300. How many tens did I jump? 2, which means I've jumped 20. Okay, now I'm going to go from 300 to 600. Well, that shouldn't be too terribly hard. So 300, 400, 500, 600. So I went 300. Oh, look, and now I'm going to go from 600 to 630. That's an easy one. I'm going to go to 30. Okay, here we go. Let's add those together. We're going to rearrange, put our hundreds together, our tens together, and our ones together. Remember that's our commutative property. So 300 plus 20 plus 30 plus 6. Let's group these. All right, so now I have 300. 20 plus 30 is 50, plus 6 gives me 356. So Sarah has $356 left. Man, Sarah's rich. She's got a lot of money. I would really like to be Sarah right now. All right, now I want you to try one. It says Jason owns a bookstore. He sold 123 books in the morning and 548 books in the afternoon. How many books did Jason sell in all? Your job is to fill in our diagram and see if you can figure out how many books Jason sold in all. I'm going to give you just a minute. Let's take a look. Well, let's see. I'm trying to figure out how many books Jason sold in all. So I'm trying to figure out my sum or my total. So this, my whole, is the piece I don't know. I do know that he sold 123 books in the morning and 548 books in the afternoon. So I know that if I add 123 books from the morning and 548 books in the afternoon, together, that will tell me the total number of books that he sold. So I'm going to solve this equation, 123 plus 548, to get my unknown number. All right, here we go. Let's add those together. I'm going to represent these using base 10 blocks. So 123 plus, 500. 1, 2, 3, 4, 5, 48. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Now I just have to add all those together. All right, so 8, 9, 10, 11. So I've got 11 here. Let's count by tens. 10, 20, 30, 40, 50, 60. I ran out of room down here. Let's count our hundreds. 100, 200, 300, 400, 500, 600. Oh my gosh. He sold a lot of books. 600 plus 60 plus 11. Let's see. 600 plus 60 is 660. I can break this apart into a 10 and a 1. So 660 plus 10 is 670. Then if I add that last one, I've got 671 books that Jason sold. That's a lot of books. If you got this, give yourself a nice big pat on the back. That's a lot of math that you did today. For your challenge today, I want you to try to think outside the box a little bit. You're going to be an author, and you're going to be a how-to author. This is really fun. All you need is just a piece of paper. It can be lined paper, or it can be computer printer paper. And you're going to fold it in half. On the front, you're just going to make a how-to. So I wrote how to use a bar diagram by Mrs. Hoffman, and then I drew a little picture down here. When you open it up, on the inside, you're going to do just a couple of things. Well, first, you need to explain to your friends or your family, well, what is a bar diagram? How does it work? And then you're going to answer this question, how can I use bar diagrams to solve word problems? Well, how did we use what we did today? How do we use bar diagrams to solve problems? And then this is the hardest part. You're going to make up your own word problem. Your job is to write your word problem here, have your family answer it, but just to make sure you've got it on the back, you're going to solve the problem that you created. That way your friends and family can check their answer on the back. This can be a lot of fun. You can be really creative, make it nice and colorful, but remember you have to use lots of details in your writing. Today's code word is pineapple because it is one of my very favorite things to eat, and it's a great summer food. I hope you had a great time today and that you learned lots of new things. I'll see you next time. Bye, friends.